So here we're working with fractional exponents, and I think the key definition to remember for all of these, I'll write this down here, is that when we have the nth root of some number b, we're going to define that to be, in terms of fractional exponents, as another way to write that is b raised to the 1/nth power. So for example, if we have the square root of 5, we can rewrite that as 5 to the 1/2 power, because there's an implied 2 in the squared radicand there. So look, those are equivalent ways to think about it. So that's the thing we'll do here first. We have an a cube root of r. Well, by definition, we can just apply what I just talked about there, r raised to the 1/3 power. And there's no further simplification needed there. For b here, we'll start off by simplifying what's inside the parentheses. Well, the 5th root of a, by definition, is the same as the a to the 1/5 power. And this whole thing is squared. And the same rules of exponents apply even when they're fractions. So we have a base number raised to an exponent, all raised to another exponent. Those will multiply. So we have a to the 1/5 times 2. 1/5 times 2 is the same as 1/5 times 2 over 1, which is the same as, which will simplify to a to the 2/5. So here we have the 6th root of c to the 3rd power. Well, we're just going to apply the definition. Underneath the radical, we have c cubed. The whole thing, by definition, when you take the 6th root of it, is the same as raising to the 1/6 power. Again, we can use the same rules of exponents here. C to the 3 times 1 over 6, which is the same as c to the 3 over 1 times 1 over 6. C to the 3/6, and we can simplify that. 3 over 6 is the same as 1 over 2, so it's c to the 1/2. So that was just a fancy way of writing the square root of c. Explaining using rules of exponents why it makes sense to define the square root of a number as a to the 1/2. Well, if we have a square root, something that equals the square root of a number, we'll call it a. Well, I'm just going to use boxes right now. If the box equals the square root of the number, if I take the box and multiply it by itself, I should get a. So let's see, it's saying, well, let's try, if we put a to the 1/2 in the boxes, what do we get? We have a to the 1/2 times a to the 1/2. Well, if we simplify that using our standard rules of exponents, we have two numbers with the same base. You just add the exponents. A to the 1/2 plus 1/2. Well, 1/2 plus 1/2 is 1. And that just equals a. So what this is saying is, if I take this thing called a to the 1/2 and multiply it by itself, I end up with a. Well, that's the definition of a square root. And so that's why it makes sense to think about the square root of a as being also defined as a to the 1/2 power. There are many ways to go about simplifying these types of problems here in 6. The simplest one I like, the approach I like to use is just try and write everything in exponents. So in its prime factorization to see how that will work here. So this one might be simple. You could just say, ooh, that's the same thing as the square root of 49. So that's going to be 7. And you'd be fine. That'd be a fine way to do this one. Another way to think about it, though, is that 49 I can rewrite as 7 squared. And that's all going to be to the 1/2 power. If I apply the rules of exponents, I have something to a power, all raised to a power. Those exponents multiply. So I have 2 times 1/2. Well, 2 times 1/2 is just 1. So maybe that was a long way of getting to the same answer of 7. In this case, we think, is there a way to rewrite -8 as something to a power? Well, we know that -2 times -2 times -2 is going to equal -8. So yeah, we can. -2 to the third power, all raised to the 2/3 power. All I did is rewrite -8 in this fancy way. And now we can go ahead and multiply these exponents because we have a base number raised to a power, all raised to another power. So -2, and then I'm going to multiply these exponents. 3 times 2/3, these thirds will cancel. We have -2 squared, and -2 squared is simply +4. And here, 32, might need to think a little bit, but if you remember your powers of 2, you know, we have 2, 4, 6, 8, 16, 32, so it's 2 to the first, second, third, fourth, fifth, sixth. So I had to pause there. This is not part of the power series. 2, 4, 8, 16, 32. So 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, 2 to the fifth. 32 then I can rewrite as 2 to the fifth, all raised to the 4/5 power. And then we just multiply those exponents again like we did there in the prior two problems. 5 times 4/5. Those 5s will cancel, which is 2 to the fourth. 2 to the fourth is simply 16. Okay, and 7 here, we're going to write some more fractional exponents in simplest form. I'm just going to rewrite this as a to the 3/5, all raised to the 15. And just like in number 6, we're going to multiply those exponents. A times 3/5 times 15, which is a. I could either cancel, or if you like to multiply everything out, you're going to get a to the 45/5, excuse me, which is just going to be a to the 9th power. Here on B, different ways you could approach this. Some people like to get rid of the negative exponent first. Others like to just start doing the rules of exponents. That's maybe where I'll start. So if I rewrite this as x to the 3/2 power, all raised to the -2, I can apply the rules of exponents like I normally do here. I don't have to worry about the fact that it's negative yet. So we get x to the 3/2 times, and I'll just write that as -2/1, which is equal to x to the -6/2, which is the same thing as x to the -3rd. And if I rewrite that without negative exponents, I just rewrite that as the reciprocal and change the sign to the positive exponent, and we get 1/x to the 3rd. And the last one here, I'm going to use a similar approach here. I'm going to rewrite the stuff inside the parentheses with, in terms of powers if I can. Well, 16 I know is 2 to the 4th. Y to the 8th I'll leave as is. And just same rules of exponents. Don't worry about it that it's a fraction. Apply. So we're going to 2 to the 4th times -1/4. It's almost like I'm distributing that 1/4 to each of those terms. And then we get y to the 8th times -1/4. 2 to the 4 times -1/4 is just -1, so that's going to turn into 2 to the -1. And then y raised to the 8 times -1/4 is -2. And then I just need to get rid of those negative exponents. So I'm going to send those to the denominator. So we keep 1 on top. 2 to the first will go on the bottom. Y squared will go on the bottom. And I'm left with 1/2y squared. as the simplified form.